Does this apply here? Is there going to be a finite sum? No, there isn't. And here's how. Here's how you can see this. If you take that formula, 1 minus r to the n, 1 minus r, what happens to this expression if the ratio is bigger than 1? If you take a number like, a simple number like 2, and raise it to a bigger number, what happens to this as n gets larger and larger? Gets larger and larger. What happens to 2 to the n, or 3 to the n, or 5 to the n? It's getting bigger and bigger. It doesn't trail off to nothing, right? Like on this calculator. Remember it trailed off to nothing? If I start with 2, and then I repeatedly raise it to a higher and higher power, what's happening to this? This eventually is going to max out and say it's overload, it's beyond what it can do. This is becoming a bigger and bigger number. The limit is infinity, not 0 like over here. If you keep letting that go and go, this is like a times 1 minus infinity. 1 minus infinity. 1 minus infinity. That's really hard to figure out what this is. 1 minus infinity. 1 minus r. 1 take away infinity. Go 1 in this direction, and then go forever in that direction. Where do you get to? Not minus 1. You go, infinity is not finite, it doesn't end, right? If I tell you to go 1 in this direction and then go forever in that direction, or I just say, you know what, just go forever in that direction, you get to minus infinity in either case. I know I am, thank you. Now I'll just have to split it, that's okay. I know people say, you know, oh, infinity, well, infinity plus 1, that's bigger. It's not, right? Infinity is going forever in that direction. If you go forever to the right, whether you started at 1 or you started at 0, infinitely means it doesn't stop. It's infinity. Infinity is not a number. It's a concept. It's forever in that direction. Anyways, if you do this, 1 minus infinity, this ends up, this is an infinite, there's no finite sum here, right? A times negative infinity over 1 minus whatever the ratio is. There's no finite sum for that. This formula does not apply here. So what you should put up here, or you should highlight for yourself, provided that the sum does exist. It only exists when the absolute value of the ratio is less than 1. It doesn't exist otherwise. The reason I show you that, is because grade 12s tend to like to memorize how to do questions. And if I ask them to add up these numbers, 1 plus 2 plus 4 plus 8 plus ... and I say, find the sum. They say, oh, so it's infinite. Even if I say, find the sum of this infinite geometric series. So I even tell them, find the sum of this infinite geometric series. You would be surprised as to how many people say, oh, infinite geometric series, what's that formula? It's this one, a over 1 minus r, because I studied until 3 o'clock in the morning last night. What do? I put in 1 minus, what's the ratio here? 2, 1 over negative 1. It's negative 1. Yes, there I got it. It's negative 1. And then they say, oh, look, it's multiple choice. My answer's there. It's got to be right. I think a grade 8 has a better chance of answering that than you if that's your approach to it. While it's important to be able to remember formulas and stuff, if the grade 8 looked at this question and saw that one of the possible answers was negative 1, I'm pretty sure the grade 8 would rule that one out right away. Because the grade 8 approaches it from just looking at what the question means. I'm not saying there's anything wrong with you guys, but sometimes you forget to think about what the question means because you've trained yourself to all the different things you're working with and you're trying to, remember it all. Make sure you think about the question. If I say start counting at 1 and then double the number and keep going forever. Now add the numbers up. I'm pretty sure you can, even at the first 4, you can say, well, it's already 15, and what's happening to the total? It's going up, right? It's getting higher and higher. There's no way it's -1, right? You have to know that this is wrong. Look at your answer and see if it makes sense. The answer here is it's infinity, or there's no finite sum. Okay? There is no finite sum. And the thing is, even if that's multiple choice, I pretty much have to make one of the answers, right? So if it says -1 and I don't know what else, and the other one is no finite sum, look at the other answers. Even if you don't stop and think about what the numbers are, just don't forget to think about the question when you look at things, or think about what you're working on. So when I say here, find the sum of each infinite geometric series using the formula, I guess I could have said provided it exists. You need to think about, does it exist or not?